On the last episode, I showed you how to read pulse width modulation signals from an RC hobby controller, much like this one, and turn it into something that could drive motors from an Arduino. Unfortunately, we only used one channel, which meant your robot could only drive back and forth. On this episode, I'm going to show you how to mix two different channels together to get steering on your bot. When it comes to driving ground-based robots, there are two popular control schemes. The first is tank drive, which is where you have two joysticks that can move back and forth. These directly control the motors on the corresponding sides and is extremely easy to implement in code. To drive the bot forward, you push both sticks forward. To turn left, you'd push the right stick forward, and to spin left, you'd push the right stick forward and pull back on the left. Likewise, to go backward, you'd pull back on both sticks. This control scheme can be difficult to master, however, many teams in FIRST Robotics swear by it. That being said, the other control scheme, known as arcade drive, can be quite intuitive to gamers. In it, we only use one joystick, but that joystick can move left and right as well as back and forth. The downside is that we need to write some code to mix the two channels together in order to control the motors on the bot. To do that, we'll use channels 1 and 2 on the receiver, which correspond to the different directions on the right stick. We'll call the back and forth direction Y and the left-right motion X. Ideally, we want it so that when we push forward on the stick, the robot drives forward, and when we pull back, it drives back. Then, front right and front left steer the robot in that direction so it turns slightly. Pushing the stick all the way left or right should cause the robot to spin on a dime in that direction. Now, in a perfect world, we'd have the robot perform a back up and turn maneuver when we hold back left or back right, but this is quite complicated to do in code. So we'll use a simpler scheme and just have to adjust for backward driving with practice. Here, I made a table showing how I want my X and Y axes on the joystick to map to left and right motor speeds. With the joystick in the middle, 0, 0, we want the motors to stop. To accomplish our mixing, we'll simply add Y and X to get the speed of the left motor and subtract X from Y to get the speed of the right motor. If the joystick is forward, then X will be 0 and Y will be 255 from our previous code. This means that both motors should drive forward at full speed, 255. To turn right, we set the left motor to X plus Y, which is 510. We'll make sure to constrain that number to 255 in our motor code, and by setting the right motor to 0, the robot should turn right. Spinning consists of turning the left motor in one direction and the right motor in the other. Everything works as intended except for our back right and back left turns. Spinning the right motor backward at full speed actually causes the robot to turn back right instead of back left, and similarly for the back left maneuver. These might seem like deal breakers for driving a robot, but it's actually pretty easy to compensate for with a little bit of practice. Erik Josh, who competed in last year's AVC and will be on later in the episode to answer a few questions about his robot, shared this mixing scheme with me, so many thanks to him. Before we write code, there's one trick I want to show you to make your code a little more streamlined. Here, I'm measuring the PWM signals from the receiver. Channel 1 is on top in yellow and channel 2 is on the bottom in blue. Notice that channel 1's pulse is output first. You might think we should sample channel 1 first as a result, however, there's almost no space between channel 1 pulse and the channel 2 pulse. To make things easier, we'll measure channel 2 before measuring channel 1 so that we read this pulse and then we read this pulse. Using the same circuitry as last time, I'm going to add a wire from the channel 1 signal output on the receiver to pin 10 on the Arduino. In the test code from last time, I added pin 10 as the channel 1 pin. Notice that I measure the pulse width for channel 2 first and store it as Y. The pulse width for channel 1 will be stored as X, which corresponds to the left-right motion on the stick. We run each of these values through our pulse2PWM function. If you need an explanation of how this function works, check out the previous episode. Now that we have motor PWM values between -255 and +255, we mix them together by adding X and Y to get the speed and direction of the left motor, and subtract X from Y to get the speed and direction of the right motor. Then we print our X and Y values to show the joystick position, and then print the left and right motor values. Upload this and open a serial monitor. When the stick is centered, the motor should be off. When I push the stick forward, both motors should drive forward at full speed. Forward right causes just the left motor to drive. Don't worry about it being over 255. We'll constrain it to 255 in our motor code. Pushing the stick right causes the motors to spin in opposite directions, which means the robot should be spinning. Similar things happen to the motors when I push the stick in the other directions. Back in the code, I've added the motor drive function and control of the driver pins. After reading the X and Y position of the stick, I convert it to motor PWM values and mix them together to get the left and right motor drive values. These are then sent to the drive function. Once again, I recommend checking out the previous episode to see how the drive function works. Upload this code to your bot. Now, when I move the right stick on my controller around, the bot moves in that direction. Pushing the stick left and right causes the bot to spin in that direction. Driving backward is the only thing that's not really intuitive, but with some practice, it's easy enough to get the hang of. To help demonstrate Arcade Drive, I have Erik Josh here with me, who competed in last year's ABC, and he did so using a robot made out of a cardboard box. Thanks for joining us, Erik. What can you tell us about the design of your bot?
So, I was the kid who always wanted to build a robot, but it took until I'd been working at SparkFun for 3 years before I got brave enough to take the plunge and built the box. This box is actually a robot that I designed to compete in ABC last year. So many of the competitors take it very seriously. They put huge amounts of time making incredibly strong and powerful robots, and I went the other direction. I made it scrappy, repairable, simple, and relatively quickly right before the competition. I wanted to use as few parts as possible, so I ended up with a single joystick, leading me to have to use that arcade drive that you were explaining earlier. I started trying to design it to handle driving forward one way and turning left a different way and backwards yet another way, and that got so complicated quickly, I found that simpler code that you were explaining. It wasn't quite what I was looking for, but it was easy enough to pick up that I figured this is good enough. 2 days before the competition, I figured, well, I guess I've got a bot now.
Nice. So how did it fare in the competition?
So I ended up not driving at all during the competition. I was technically working, so I figured I shouldn't play. When it came time for the box to go into the arena, I got a kid from the audience and handed them the remote. The first match could have gone better. It went against the bot that ended up winning second place in the ant weight category, which was an undercut bar spinner. It ended up snapping one of the wheels off, and the other bot clearly won. But for its second match, I was able to quickly repair it, and the kid that was driving it was able to outmaneuver the other bot driven by someone who built their own.
Wow, congratulations, and thanks again for sharing with us your design. And there you have it. You can indeed create a competitive robot for combat bots using cardboard box and simple components. Keep working on your destruction machines, and we'll see you October 14th at ABC. Happy hacking. Much like this one. And it did stuff. On the last episode, great start, Sean. Great start.